Hi, in this video, I am covering how you can make ChatGPT for your own data or documents. This data or documents may be website data, PDF, blog, Notion pages, etc. Or maybe database also. We are using GPT 3.5, Langchain, ChromaDB, and sentence transformers for building this LLM app. We are going through official Langchain document because the Langchain official document is very helpful and they are covering everything you want to build a LLM app. We are following this document to build our LLM app. First of all, we can look what the pipeline we are using here. This is the image they are describing. So first we are loading the document. Suppose we have documents like in URL, PDF, or databases. First, we are loading that document. Then after that, we are splitting. Suppose our document may be hundreds of pages. So we want to split that document into small chunks. After the splitting, we are storing that in a vector store. We are covering vector store in detail. After that, we are retrieving that relevant split. That means when a query or a question come to us, we are retrieving the relevant split from our vector store. Then we are giving that content. That means that relevant split to the LLM, and we are getting answer. This way we are building the LLM app. Here you can see everything they are explaining here. The loading, first we need to load our data. Maybe unstructured data can be loaded from many sources. Then we are splitting. Then we are storage. We are using vector store. You can see what actually vector store is here. So one of the most common ways to store and search our unstructured data is to embed it and store the resulting embedding vectors. We are doing here, first of all, we are embedding our unstructured data and storing in a vector database. And then at the query time, to embed the unstructured query and retrieve the embedding vector that are most similar to the embedded query. Then we get a query, we are also embedding that query, and we are retrieving the embedding vectors that are most similar to the embedded query. A vector store takes care of storing embedded data and performing vector search for you. They are explaining here everything you want to know about the vector store and how actually that is working. Here we are using the ChromaDB. You can use the other two also. Okay, we are following this document to build our LLM app. So we are going to copy this. I'm using Jupyter notebook. So I am installing this. Pip install OpenAI ChromaDB. I am also installing sentence transformers because in this blog they are using OpenAI embeddings for embed our document and query, but here I am using sentence transformers because the OpenAI embedding is a paid, my limit is exceeded in free trial, so I am using sentence transformers. You can use OpenAI embedding also. Then I am running this. Here you can see the requirement is already satisfied because I already installed all these. Yeah, okay. The next thing is first is step 1, load the data. Yeah, you can see, yeah, you can read this is specify a document loader to load your unstructured data as documents. A document is a piece of text and the page content and associated metadata. Here I'm copying this code, paste it here. You can see from Langchain document loaders import web-based loader. The web-based loader is used to load data from website. You can also use another loader for document loader from your own PC, from your directory. That you can see here. I show you that Langchain document loader. Yeah, this is that. You can see the, from Langchain document loader is import text loader. You can also use CSV loader, file directory. Yeah, from directory loader you can load all files from the directory. That may be CSV, PDF or doc. There is no problem. You can use this API for that purpose. But here I am using web-based loader because I am using website data for our LLM app. So instead of this URL, I am using another website data. That is, I already opened here. This is a blog about Chandrayaan 3. I am loading this and running this. Yeah, it is running. If you want to go deeper, you can click here and read about that. After that, we are splitting. Now we loaded our document in this variable, data variable. After that, we are going to split this. That means our data may be hundreds of pages or a big data, so we want to split that for easy storing and retrieval. So I'm copying this code. You can see from Langchain to text splitter, import recursive character text splitter. We are using this API. You can also use another splitter. You can search here Langchain splitter. Yeah, text splitters. There may be many text splitter, recursive character splitter, character text splitter. You can read everything from here. I'm using recursive character splitter. Then chunk size is 500. That is the maximum size of a chunk. And the chunk overlap by here I am using 10. I am creating the instance of recursive character splitter as text splitter, and I am using text splitter instance to split the document. Yeah, that's all. After that, we are storing. Now we splitted our documents. Now the all split is here in the all split variable. You can see here all splits. Yeah, this is the all split. You can see here. Yeah, Chandrayaan 3 successfully land moon's south pole, like that. Yeah, we can also check the length of the chunk, how many chunks we have. Yeah, we have 34 chunks. You want to, okay, now we are storing. Now we splitted all the documents. Now we want to store that in a vector database. So to able to look up our document split, we first need to store them where we can later look them up. The most common way to do this is to embed the contents of each document, then store the embedding and document in a vector store, with the embedding being used to the indexed documents. This means now we splitted. Now we want to store in a vector database. To store in a vector database, first of all we want to embed that. We want to embed that whole document and store in a vector database along with the embedding which we are using. In this document, first of all we are copying this. Sorry. And copying this. So you can see from Langchain embeddings, import OpenAI embeddings. But in here you can see they are using OpenAI embeddings, but I am using sentence transformers. Yeah, this is sentence transformers embeddings. This is free. Then after from vector stores, import Chroma. Chroma is a vector database. We are using Chroma for that. Then here Chroma dot from documents. Then we are passing documents as our all splits, and embedding as here we have to change into sentence transformers. First of all, we have to do another thing also. Embeddings. In here you want to specify the model which you want to use, so we can search here. Yeah, you can use this model. I tried this model. This is very good. Yeah, and this in here embedding, we are passing these embeddings. Yeah, this may take some time because we are embedding our documents. Yeah, that's done. If you want to go deeper, you can check here. I'm not going to deeper. After that, we are retrieving. We embedded our documents, then we are going to retrieve. Copying from there. Then we are asking, if you ask any questions, suppose this question is related to Langchain's documentation web page. I am questioning from our own web page, that is suppose I am asking why did Chandrayaan choose moon near side of landing, and copying this question and give it to here. You can see that we are passing, we are assigning a question for question variable, then from vector store dot similarity search we are passing our question. This vector store is the vector store that we are created earlier, this thing. Then from that vector store we are doing the similarity search. We are here we are using question similarities to search. Then we are passing the question from the, based on this question, which is the most similar chunk, that will return to the docs. And I am printing that dog, suppose. Yeah, you can see this is very fast. Why did Chandrayaan 3 choose moons near side of landing? Yeah, here we got around 4 chunks. 1 2 3 4 chunks related to this question. These are the 4 chunks that is most related to our question. So if you want only in 1 or 2 chunk, and you can specify the number of chunk returned. So I given 2, then it will only give me the most 2 similar chunks, the 1 and 2. Yeah, if you want to go deeper, you can click here. The next thing is the generating. This is our actual part is happening, actual question answer is happening. I'm copying this. Yeah, from Langchain dot change import retrieval QA, we are using this API. And from Langchain dot chat models import chat OpenAI. And here we are specifying the LLM which we are using. From chat API we are using GPT 3.5 turbo and the temperature equal to 0. Then in the QA chain we are using retrieval QA from chain dot chain underscore type. We are passing the LLM and the retriever means the from which vector store we want to retrieve our document. And here we are calling that with our question. The question is we already assigned here, but I think this will get a error because we are not passed the OpenAI API key. So we want to set this. To set that, okay, here and import OS and OS dot environ OpenAI API key. Then give your API key here. To get the API key, go to OpenAI API key website, then sign into OpenAI website. I already signed in. You can choose API. From here you can click view API keys, then create a new secret key. From here you can type anything, suppose QA. Then create secret key. Yeah, then I can copy this. This will only show one time. You want to store it anywhere. So here I am passing this. I will delete this key after this video because this is secret thing. So I am, yeah, now I assigned to open API key as this. Now I can run this. It will give me the answer, I think. Yeah, Yeah, you can see here our query. Why did Chandrayaan 3 choose moons near near side of landing? This is our question. You can see here. Yeah, then from the result, Chandrayaan 3 chose the moons near side of because it aimed to investigate the permanently shadowed regions. You can check is this correct or not. Yeah. Yeah, this is the question we are passed. The answer is this Chandrayaan 3 aimed to investigate permanently shadowed region. Yeah, in here you can see Chandrayaan 3 state of landing because it aimed to investigate the permanently shadowed regions. Yeah, this answer is 100% correct. Yeah, we can play with many other questions and answers. So giving here the question was what is another question. Suppose we give this. What are the intended actions of Chandrayaan 3 after its landing? We type enter. Yeah, you can see that after its launch, Chandrayaan is expected to operate for at least one lunar day. Yeah, you can see Chandrayaan 3 expected to operate for at least one lunar day. Okay. I suppose you want to know what is the full form of LoopX. Yeah, we can ask also that. What is the full form of what is the LoopX? LoopX. Yeah, the full form of LoopX is lunar polar exploration. If you want if you only want to need only answer, so then you can do this. Sorry. Yeah, you can only get this answer using this way. The full form of LoopX is lunar polar exploration. You can ask anything about that. What are the ISRO's future expeditions? Sorry. Then list all the points. Here this. If our prompt is very good, then we get a good answer that we are expecting. Yeah, you can see Chandrayaan 4 LoopX. Yeah, Chandrayaan 4 LoopX Aditya L1. Yeah, Aditya L1 minimum. This is very accurate. We are getting, I think, 99.9% accuracy here. Suppose you have a doubt what we asked the questions that is not included in this website, so we can check that here. Because I am asking what is Langchain. Here you can see that I'm sorry, but I don't have any information about that. It doesn't appear to the term of the concept that I am familiar with. Yeah, you can see that is not answering. That is outside from this website. What I'm asking what is vector database. Yeah, I'm sorry, but I don't have any information about vector database in the given context. Yeah, this all for this video. I think Yeah, that's all. If you have any doubts, you can comment it, or you can directly message me on LinkedIn. I will clear that. I will put my LinkedIn profile link in the description box. And I am also giving you the link of my GitHub repo of this project. Thank you for watching.